Today we're going to talk about estimating square roots. We previously learned that square roots are the number that times itself would give us 8. In this case, do we know a number that times itself gives us 8? No. No, we don't. So to estimate, we're just going to get as close as we can to the nearest whole number. So square root of 8, we don't know. How about some ones that we know around there? Okay, how about the square root of 4? You know, that's 2. And the square root of 9, that's 3. Now, because we're estimating to the nearest whole number, in this case, we're going to estimate to the nearest whole number. It's 8 closer to 4 to 9. It's a lot closer to 9. So for this one, if we're estimating to the nearest whole number, we're going to go with 3. Now we know that this number is going to be a little bit less than 3 because 3 squared would be 9. So this might be, if you're estimating to the first decimal place, you might say 2.9. Maybe that would be your guess. But if we're going to the nearest whole number, we're going to go to 3. This is essentially how basic estimating square roots is going to be. It's pretty straightforward. Now, if you don't have at your disposal a chart of all the square numbers up to like 25, I would create one. If you have something like that, it'll be really easy to reference these until you have them memorized. So let's look at a couple more examples. Our first one here is 38.5. Estimate the square root. We're going to estimate to the nearest whole number. Now, we see this decimal here. Is that going to change this? And I'm going to tell you it's not. That's not going to change anything. We're still going to estimate to the nearest whole number. So the nearest perfect square to 38, that's below, it's going to be 36, and that equals 6. Next one above, it's going to be 49, and that equals 7. Now, is 38.5 closer to 36 or 49? In this case, we're going to go with the 36. So our answer for this one would be 6. We're just rounding it to the nearest whole number. We're estimating. You know, we're not calculating these, which if we were, it would be pretty nasty. You'd want to use a calculator for something like this because it's going to give you a big long decimal. You're not going to calculate this by hand. Okay? And if you did calculate it, you're going to round it. You're going to round it sooner or later at some decimal point. In this case, we're just rounding to the nearest whole number. Okay, 125. We're getting to some bigger numbers. Some of you might know off the top of your head. You should. 10 times 10 is going to be 100. I'm going to let you know that we can actually get one closer, and 121 is a perfect square of 11. After 11 comes 12, which is 144. 125, closer to 121 or 144? We're going to go 11 on this guy. It's only 4 away from 11. It's only 4 away from 121. We're going to round this down to 11. Okay. Again, part of this is just going to be becoming comfortable with knowing your perfect squares. Once you have all your perfect squares memorized up to a certain number, estimating these will be a lot easier. 59. Okay, well, how about let's start with 49. That's the one below. That would be 7. If we went up, next one up would be 8 squared. We're at 64. Okay, so 59 is 5 less than 64, 10 more than 49. This guy, going to say the answer is 8, rounded to the nearest whole number. And that's essentially all there is to rounding these perfect squares, is we just look at the ones closest to it, below and above, see whichever one it's closer to, 8, 11, and 6, and we find our answers.